Okay, I just wanted to record a quick little video for you to finish up the day 5 notes that we started yesterday. So you can watch these and then hopefully that'll help you with the um, free response sheet that I gave you yesterday, and you can use the rest of the class time to work on that. Okay, so we're talking probabilities. There's lots of different kinds of probability questions. So I'm just trying to show you how to determine what kind of probability problem you're dealing with. So the one we're going to look at right now, these are called random variables, and they're probability questions. And oftentimes you're going to see them presented to you as expected value problems. So it'll say, what is the expected value? You might see something like that. These are the formulas on your formula sheet for mean and for standard deviation. Well, actually, this is the variance. If you want the standard deviation, see how this is the standard deviation squared? So if you want the standard deviation, you're going to have to do the square root of the variance. So you'd have to do the square root of that, and you'll get the standard deviation. Now, here's the big thing about your calculator. Because these problems, these expected value problems, you're often going to see a table. Sorry, this is hard to write with. Hang on. You're often going to see a table with x and then the probability of x. And then you're going to have, like, let's say you're playing a game and you win $1 if you do something, and the probability of that is 0.3, and then you win $2 if you do something else. And you fill this whole table out, and it's asking what's the expected value. And when we were doing it with games, it was a fair game if the expected value was 0, if you remember that. So here's the thing. You can type all this in your calculator. You can type into 2 different columns, and then you can get the mean, which is the expected value, by doing menu 411. Okay, so that's what I have written here. Put your x values in column 1 and your probabilities in column 2. You're going to do menu 411 to get the mean and the standard deviation. But it's going to ask you the number of lists, and you're going to want to put in 2 because it looks like you just typed in 2 lists. But you select 1 instead of 2. And then you're going to change the frequency to the probabilities that you had in the second column. So let me just show you what I'm talking about. Okay, so here's our probability distribution. And we're going to get the calculator. And we're going to type them in the calculator. So we're going to go to our spreadsheet. Type them in. And then go back up and give it a label. So I'm going to say, oh, I'll just do like what's in the table, y and py. Okay, now we're going to do the menu 411. Menu, statistics, stat calculations, one variable statistics. And a lot of people are going to want to change this to 2 lists because, hey, you just typed in 2 lists. But keep it at 1 and hit OK. The X list I called Y. The frequency list we changed to the probabilities. Okay? Then you hit OK. So right here, this X bar, 2.73, that's the expected value. Okay? And the standard deviation, you got to go down a little bit. Right here is the standard deviation. That's 1.25582. Okay, so if you're using your calculator and you just you're doing a problem on the AP test and it's asking you for the expected value, don't just write 2.73. So don't just write 2.73. You got to at least write the formula out. So go back a page. Here's your formula. Okay, the expected value. So write that formula out. Okay, and did I forget anything? Let's go back and look. Nope, looks like I got it all. Okay, so that's the bare minimum work. Write the formula, write the value. Otherwise, if you want to do it by hand, you certainly can. You would do the top number times its probability plus the next number times its probability plus the next number times its probability. So you certainly could do this, or you can just do it in your calculator. But at the bare minimum, you have to write the formula. Okay. Now, if we had to interpret, okay, let's interpret this. So this is what we would expect to get in the long run. So make sure that you kind of indicate over the long run. So I would say, and this is a given week. So I would say something like over the course of many weeks, we would expect Jim, that's the guy, we would expect Jim to work 2.73 days per week on average. Because this is about the number of days Jim has to work in a given week. Okay, so that's how we would interpret the expected value. So now if it says find the variance, well, when we had the calculator, remember how the variance, the standard deviation was 1.2558. We got that on the calculator, so you can go back and look. The variance is the standard deviation squared. So we're just going to do 1.2558 squared, and we get the variance of 1.577. Okay, next page. Okay, random variables. This was that whole like delicious dogs worksheet. So what this is saying is if I want to add the means of two random variables together, I take the mean of one plus the mean of the other. I can just add them up. If I want to subtract two random variables, I can subtract their means. But then look at the variances. So if I'm adding two random variables, I can add their variances. So if I wanted the standard deviation, if I just wanted the standard deviation of these two random variables, I would take the square root of those variances added up. I cannot split this up. I cannot say that I can cancel the square with the square root and just say the standard deviation of x plus the standard deviation of y. That's not true. So you cannot add the standard deviations. You can add the variances and then take the square root to get the standard deviation. This is one to be careful of. Even when you're subtracting, you still add the variances. If you're adding a constant, you can go ahead and add that constant onto the mean. But adding a constant does not change the standard deviation. So like the standard deviation of when I'm adding a constant would be the square root of that variance. So standard deviation does not change if I'm adding a constant. If I'm multiplying by a constant, I can multiply the mean by that. But I would multiply the variance times that constant squared. Okay, so you're going to want to take a look at this page and familiarize yourself with it again. Here's an example of where we used all this stuff. Okay, so for our particular salesman at a company, the number of units he sells in 1 month is approximately a random variable m with a mean of 4.12 and a standard deviation of 1.39. Okay, so they're specifically saying that this salesman, we're calling him M, this is his mean and his standard deviation. So I'm just going to write that information. The mean is 4.12, the standard deviation is 1.39. Okay, then it says we've got a new salesperson, the new person. Again, approximately normal random variable, n for new, this time with a mean of 3.36 and a standard deviation of 0.88. So I'm just going to write that down. So the new guy's mean is 3.36 and the new guy's standard deviation is 0.88. Okay, so I'm just writing down what I know. What is the probability that the two salesmen sell more than 10 units, like together? So it's talking about approximately normal. That means we're going to use z-scores. So in order for us to use a z-score, we need a mean and a standard deviation. But we need the mean of the two of these salesmen together. So I need to find the mean of the m plus the n. The regular salesman plus the new salesman together. So I can add their means together. So I can just take the 4.12 plus the 3.36 and say that my mean is 7.48. Well, then I got to find the standard deviation. Well, I have to do the variance first. The variance of m plus n, I can add their variances up. And then if I want the standard deviation, which I'm going to need for my z-score, I'll do the square root of those added up. So I got to take the standard deviation of m, 1.39, square it, that's the variance, and then I need the standard deviation of n, square it, that's the variance, and when I do that I get 1.65. Okay, so here's my mean, and here's my standard deviation that I need to use for my z-score. So now I'm looking at the probability that these two guys, m plus n, sell more than 10. Okay, so now we got to do a z-score. So 10 minus the mean of 7.48 divided by the standard deviation of 1.65. And when I do that, my z-score is 1.53. This is all side work here. So the two of them selling more than 10 is the same thing as my probability of my z-score being more than 1.53. So now I'm going to go look at my z-chart, and since it's a greater than, I have to do 1 minus. I'm going to look up 1.53, and I get 0.9370. So I do 1 minus that, and I get 0.06 6.3, I believe. So 6.3% would be the